Hi everyone, I am Durga Devi, Assistant Professor from SNS College of Pharmacy and Health Sciences. In this lecture video, I am going to discuss about adsorption column chromatography. This video will describe introduction, principle, practical requirements, stationary phase, mobile phase, column preparation, sample introduction and elution techniques. The chromatography was first introduced by Michael Sweat and Kuhn and Ledger, and they have identified the different pigments present in plant with the help of chromatography. And the principle involved in chromatography is either adsorption or partition. It involves two phases. One is stationary phase and another one is mobile phase. The stationary phase is a fixed one that is immiscible, and the mobile phase is a one that kept moving. The classification of chromatographic methods based on column can be categorized into liquid chromatography and gas chromatography. In liquid, PC, that is paper chromatography, thin layer chromatography and high performance thin layer chromatography. And in a liquid solid, it is adsorption principle, and the example of that is adsorption column chromatography and HPLC. And in gas chromatography, it can be classified into gas solid chromatography and gas liquid chromatography. And the other LC types are ion exchange, affinity and supercritical fluid chromatography. And in that we are going to see about column chromatography. The column chromatography involves a column in which the adsorbent or the stationary phase will be filled inside the column, and the mixture of sample will be applied from the top of column, and with the help of mobile phase it will move along the stationary phase in different timings. That is the substance with the high affinity towards the column will move slower, and the substance with the lower affinity towards the column will move faster. So we can collect the different fractions at the bottom of column, and the principle involved here is adsorption or partition. So adsorption is if your stationary phase is solid and the mobile phase is either liquid or gas, then it will fall under the category of adsorption. And the partition will be applied for the chromatography where the stationary phase is a liquid and the mobile phase is either liquid or gas. So you can see the mobile phase is kept inside a chamber, and the stationary phase is kept immersed inside that mobile phase, and with the help of this mobile phase the sample spot is moving against the gravity, and the distance moved by this solute is measured. With the help of RF values we can determine and identify the unknown compounds that are present in our mixtures. The requirements of chromatography is stationary phase, liquid, mobile phase, and column characteristics, preparation of column, introduction of sample, development technique, detection of compounds and recovery of components. The stationary phase is adsorbent in case of adsorption column chromatography, and the ideal requirements of adsorbent is it adsorbs to analyte only, and it should have uniform size like 660 to 200 micron, and most of them should be spherical in shape, and it should have high mechanical stability, and they should be inert. They should not react with either solute or the mobile phase, and they should be insoluble in solvents and colorless for zone observation. And the adsorbents and solvents. The adsorbents and solvents used in adsorption column chromatography are listed out in this table. The adsorbents can be classified based on their strength into weak adsorbent, medium adsorbent and strong adsorbent. And the example for weak adsorbents are sucrose, starch, inulin, talc and calcium gluconate, and for them we have used mobile phases such as petroleum ether, carbon tetrachloride, cyclohexane, carbon disulfide and ether. And the medium adsorbents are calcium carbonate, calcium phosphate, magnesium carbonate, magnesium oxide, calcium hydroxide, activated magnesium silicate. And the solvents we can use for the stationary phases include acetone, benzene, toluene, esters, carbon, chloroform and acetonitrile. And the example for strong adsorbents are activated alumina, charcoal, magnesia, silica and fuller's earth. And the solvents we can use for them are alcohols, water, pyridine, organic acids, mixtures with ethanol and or pyridine. The selection of stationary phase depends on the removal of impurities, a weak adsorbent if a small impurity, and affinity differences. And a number of components, if we have a few components, then we can use weak adsorbent, and if we have many samples present in our mixture, then we can go for strong adsorbent. And affinity differences among the sample mixtures, if they have similar affinities, we can go for strong adsorbent, and if they have larger differences in the affinity, then we can choose weak adsorbent. And the column length can be chosen based on if the strong adsorbent is used, we can use short column, and if we use weak adsorbent, we can use longer column. And the quantity adsorbate versus adsorbent, that is 1:20 or 1:30. The mobile phase solvent can be categorized into solvent. The mobile phase should act as a solvent, developer as well as a eluent. The solvent means the mobile phase should be able to dissolve the mixture, and it should be able to take the sample inside the stationary phase, and it should also act as a developer. It should be able to separate zones, and it should eluent. It should be act as a eluent also, because it should elute the sample solution out of the column. So these are the requirements of mobile phase. And the column preparation is dry packing or wet packing. In dry packing method, the column is filled with the adsorbent, and then mobile phase will be added. In wet packing, the slurry of adsorbent is prepared first and then poured inside the column. So then introduction of sample and elution is based on isochromatic elution and gradient elution. Isochromatic means the same solvent system is used throughout the separation process, and the gradient elution means from polarity wise we have to use different solvent composition, mobile phase composition. And the detection can be done with the help of UV visible detector or fluorescence or flame ionization, dependent on the type of sample we are going to analyze. Thank you.